Hello everyone, and welcome to this course on logical systems. So as we can see here, we have in excess of 9 routers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's not in excess, it's actually 9 routers. However, all these routers are just running on one Juniper vMX image. This is a fantastic piece of software that Juniper has implemented into a lot of their devices, their routers, there's some of their switches as well, which allows you to logically separate the actual device into multiple routers. Now, we've seen something similar in our JNCIS studies with the routing instances, where of course we could have overlapping IP ranges, etc., and have separated logical routing tables. However, with the logical systems, that goes a step further. This router here, CE1, is a complete independent router. It has access to its own routing protocols, its own router IDs, its completely own routing tables. Again, same with PE1 right here. Again, this is its own complete router. It's got all the operational functionality of a normal router, but it's virtualized automatically within one particular running node. The same with our core right here. Our core again is a virtualized router within another router. So with these, you can run things, you can run all your routing protocols. You can run your OSPF, your ISIS, your RIP, your BGP, your MPLS. You can do your tunneling, all your layer 2 services. You can do EVPNs. The list is endless. However, if we clear that screen, and if we scroll to the actual main topology that we're using, if I go to the physical topology, as we can see here, I only have one Juniper device. All of these other logical systems are running within this one Juniper device. Now, why this is actually quite good is this particular device, the control plane, is running 4 gigs of RAM and 4 CPUs, and the forwarding plane is running 4 gigs of RAM and 3 CPUs. However, as we've seen in the diagram that I'm using, we're running 9 instances of this. So this is a total of 8 gigs per image. And if we times that by 9, so 8 gigs times 9 nodes, that equals 72 gigs under full load, of course. Now that's a lot of memory, a lot of usage, and of course if you're only running a device that has, let's say your home PC is limited with the amount of memory that it can do, and you're limited with your CPUs, then trying to run a relatively big topology can be extremely frustrating and extremely slow. And due to the lack of resources, you'll find that most protocols just won't work properly, and you'll be waiting forever to boot these devices up. Now, you've seen in my JNCIA videos that I'm using a server that has 128 gigs of RAM and 32 cores. That's fantastic. I haven't always had access to devices of that nature. However, on this is working now off of my own home PC. I've just allocated, I think, 6 cores in total and 8 gigs of RAM, and that's it. But I can run 9 images absolutely fine, 9 virtual routers absolutely fine, no problem. In fact, logical systems can go up to 15 nodes and that's excluding the master node as well. So what we're going to do in the next videos in the series, we're going to explore how to set up the logical systems, how they're done. We're using logical tunnel interfaces here, how to peer between the two tunnels, and show you how to set up some routing protocols as well. And we'll amend the topology as we go along, so we can start doing some BGP, and we'll get cracking. We're maybe throwing in a little bit of MPLS, make some pseudo wires between the likes of, say, P1 and P4, you know, go using one of the IGPs for loopback advertisements. So we're going to cover quite a lot, but what you'll get out of this course is that it's going to enable you to go quite deep into your topologies without having to have expensive hardware, and especially with the cost of living that, you know, across the world now, whereby electricity is costing so much. The last thing a lot of people want to be doing is trying to run huge devices where you can actually run this particular sort of topology on a laptop, for argument's sake, and it will work fine. You know, as long as you can allocate a little bit of memory to it and some CPUs, you'll be able to duplicate this without an issue. And of course, if you're wondering how I've done this, in EVE-NG Pro or PNet, you have the ability to add pictures onto your topology, and then you can just overlay the pictures. In fact, you can actually as well assign nodes to these pictures. So if you notice, when I hover over CE1 or P1 or the top PC there or the other PC, you come up with a little hand mark that will then open up a telnet session to say PC1, PC2. But since all these are on the same device, then it's just going to open up my main device. But we'll go through how to switch between the logical instances as well, and we're going to have a great time. I look forward to seeing you in the next set of videos.